Hey everyone, welcome to the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I will answer them here. Now, I am recording this show on April 19th, which is also my sister's birthday. Happy birthday, Heisla. So I don't know what's going to happen in the coming week. Maybe SN-15 is going to fly and land safely. Crew Dragon is going to be off. Crew Dragon 2 is going to be off to the International Space Station. Maybe we'll see another flight from the Mars helicopter. The future is a mystery. And I'm sure we'll have all kinds of hilarious clips that Chad will put in there. All right, let's get into the questions. Confused Dave. One potential explanation for the Fermi paradox that I often see raised and dismissed without comment is maybe we're first. How big is the window for life-sustaining planets to have appeared? If you wonder where all the aliens are, and you sort of think about the Fermi paradox, then, and I've talked about this many times in many videos, that every explanation that includes that there's aliens everywhere doesn't seem to hold. We don't see any evidence of their robot probes crawling around the solar system, and so from that, we have to sort of assume that they're not out there. But the answers are, of course, we could be the only intelligent life in the Milky Way, or we could be the first intelligent civilization in the Milky Way. Both of those are possible, and if you sort of rule out intelligent civilizations, then there's that in the Great Filter, where something horrible is going to happen to us, like it happened to all the other civilizations, which is pretty terrifying. So we don't want to think about that. But it's really hard to believe that. Because, yeah, the universe was habitable far before even the sun itself formed. It's thought that probably about 1 billion to 2 billion years after the Big Bang, there were enough heavier elements that had been formed through various generations of stars that you would see heavier elements. And then you would see terrestrial planets, you'd see stars forming. And the Milky Way itself has been around for almost the entire length of the universe's history. The Milky Way itself formed probably 13 billion years ago. And so when you do the math, aliens have had a head start on the sun, which only formed, say, 4.5 billion years ago. They've had many billions of years to form and to completely fill the Milky Way with their robotic spacecraft, and yet we don't see them. So the universe is big, the universe is old, and life had plenty of time to form long before even the sun itself formed. And so it just makes the Fermi paradox all the weirder that we don't see any evidence of any aliens out there at all. Jimmy Carlson. Do galaxies turn like a flipping coin, or do they all slice space strictly like a frisbee? Can't seem to find the answer. So when you're imagining a galaxy around in space, and you're imagining it sort of has a disk, like the solar system as well, but a galactic disk, as they sort of are scattered randomly across the universe, whatever you see as that spinning, that is their axis of rotation, and they're spinning like a disk, like a frisbee, like you said. And so whatever angle you're seeing, that's where they're spinning. And in fact, we know that galaxies formed into this shape because of their spin. And so before you had the galaxy, you just had this vast cloud of gas and dust that formed in individual stars, and the stars collected together thanks to the gravity of dark matter surrounding them, and as it started to collapse down inward, it started to spin up. And as it spun up, it flattened out into this disc shape. And so the disc, the way you see the disc is as if it's a frisbee spinning around that axis, as opposed to if it was a coin. Now, the whole thing can be kind of turning or can be moving around in a larger area, but if you were to sort of zoom in on the galaxy, it would be spinning around like a frisbee. Rigged Gamer. Bro, get a better career. I can't imagine a better career than the one that I've got right now. I'm really grateful for the fact that I get to report on space and astronomy news. I get to choose my own hours. I get to work with the team that I like. I've been able to just collect a huge group of friends and collaborators for lots of different projects. I'm able to pay my bills. I have a house. I have a car. I was able to put my children through, my daughter's into university now. I'm able to employ many people, and I get to spend my days talking to astronomers and astronauts, as well as reaching out to the public. So I highly recommend the career of being a science journalist, a publisher, doing the path that I did. And I've tried other careers in the past. My background is in tech entrepreneurialism. I was a tech entrepreneur. I founded my first software company back in 1991. That's how old I am. And that company has gone public. I was a co-founder on other companies, and I didn't enjoy it. I didn't enjoy the work. I didn't enjoy sitting in meetings. I didn't enjoy having to work with clients. I don't like clients. I like just to interact with the general public, make things for the end user. But all of that tech skill has sort of informed the work that I do. And so I really think, as you choose your career, you really want to find something that maximizes your happiness. It's not about chasing money. It's about maximizing how much of a good time you get to have sort of day in and day out as you do your work. And then if you can sustain that work over a long period of time, 22 years now, you get to build a legacy, and you get to hopefully make an impact and improve the lives of the people that you interact with. So I literally cannot imagine a better career that I could have chosen, Rigged Gamer. But thanks for the recommendation. Matthew Nebel, do you think U.S. Congress will continue supporting bloated jobs programs like SLS now that much cheaper commercial options are coming on board, especially Starship? So we've talked about this several months, several years now, just sort of SLS versus Starship. And my opinion has always been that NASA is sort of stuck in a bind, that they've chosen to go down the path of Space Launch System, which is essentially the space shuttle revised, but safer than the space shuttle. I mean, the space shuttle had enormous heavy lift capability. It was the most complicated, beautiful, amazing machine that humanity has ever created. And as I said, it never should have been built. And the Space Launch System is the safer version of it, but still at immense expense. But you see things like Starship coming along, and the problem is that it explodes on launch pads. And so it's not the kind of thing that you can today put your money behind. And so on Friday, I guess of last week, so I don't know, the 14th, 15th of April, NASA announced that SpaceX is going to be their only provider, their only lunar lander is the Starship. I could not believe what I was hearing, that this was their choice. Not that I don't agree. I think it's a really kind of bold decision to go with. That the astronauts are going to launch on board the Space Launch System. They're going to fly to the moon on an Orion capsule. They're going to go on to a Starship. They're going to use the Starship to go down to the surface of the moon and then ascend again, dock with the Orion, and fly home on the Orion capsule. And that's crazy to think that that's what they're doing. And it sort of shows you how much faith they have in the capability of the Starship. Like, more faith than I do. So I got to go with NASA on this one. And it feels like that's still them trying to use the Space Launch System in some kind of capacity with the Artemis program. And the next step, the simpler step, I think, is to put people on a Falcon 9, on a Crew Dragon, fly to Earth orbit, dock with a Starship in Earth orbit, fly out to the moon, land on the moon, return to Earth orbit, transfer back into a Crew Dragon, which we know can get in and out of the Earth's atmosphere, and land the astronauts safely back on Earth. And they could then cut the costs of this multi-billion-dollar rocket down to a few $100 million again. So it seems like landing on the moon is surprisingly within our reach at this point. And to see that new announcement happen, when you think about it, like Blue Origin had received a ton of money, United Launch Alliance, all these other companies had to step aside for SpaceX. Like, it really feels like now is the moment where SpaceX is starting to run away with it. Imagine if they built rockets that didn't explode when they hit the landing pad. That would be amazing. And so that idea of using a starship only in orbit, like the Enterprise, like it's not built to land on Earth, that's kind of cool. I kind of like that. I'm totally fine with that. And so I think I think NASA is still forced by the government, by Congress on what it has to do. But I think you're seeing them being flexible, and eventually, I don't think Space Launch System is going to launch more than a couple of times, 2, 3, 4 at the most, and then it'll be willing to be the era of Starship. So it's crazy times. Eric 1, did you watch Ingenuity's flight? I didn't watch it live. It happened before I woke up this morning, but I definitely watched all of the video, and of course we've reported on it on Universe Today now. It's amazing. It was when you look at the animated video of it, you see the helicopter sitting on the ground, and then you see it up in the air kind of moving back and forth a little bit, and then you see it on the ground again. So it is not the best footage, and I'm guessing they wanted to keep Perseverance far enough away in case something really crazy happened and it couldn't damage the rover. Like, it was really far away, but it worked perfectly. And so now we're going to probably see longer flights, higher flights. There's a scene that was on Twitter. I forget exactly where I saw it, but I really loved it. The project manager, she had a document on all the things she was going to do if it failed, and she sort of publicly tore it up because they were successful with the flight. It's so cool to think that a helicopter just flew on Mars in that incredibly thin atmosphere. And you sort of think about what the future might hold to have these relatively simple aircraft traveling alongside every future mission. I wouldn't be surprised if each mission from here on out has many of these things attached to them to serve as scouts for their work as they drive around on Mars. It's amazing. So great. Jeff Sonderman. Hey Fraser, I'm finishing up the Three Body Problem trilogy. It's tremendous. Do you think the movie version will do it justice? No, of course not. When has a movie version done something justice? Very rarely, right? So I can't let myself I will not board a hype train, and the destination is always sadness. So movies, television shows, books, they have to stand on their own 2 feet. The connection is tenuous. But I am enjoying, I've mentioned this before, that I kind of enjoy that Hollywood is figuring out that there's lots of great books, great science fiction books that you can just adapt to a 6-part, 8-part miniseries, like The Queen's Gambit. And, they're going to try to adapt Foundation. Good luck with that. There's going to be but then there's going to be like a Dune movie, but it should be a Dune miniseries. So I think that should be the future. Anyway, if you haven't read The Three Body Problem, read it. It's awesome. I love that series, and it'll be interesting to see how it gets adapted onto the small screen. More questions in a second, but first I'd like to thank our patrons: Uvi Carvajal, Ryan Andersoff, Oren Lawrence, Daniel Fidel, Ben Murray, and the rest of our 845 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universe today. Hal McKinney, trying to decide if it would be worth the 5.5-hour drive to see SN15 scheduled for this Friday. What are the odds of cancellation? One does not book a return flight from watching a rocket launch. And I learned this lesson very powerfully when I tried to go see the second to last launch of the space shuttle in 2011. And I took my dad to go see, and I've mentioned the story many times, that sort of one of the first moments of get me starting to really love space was in 1981. My father, he'd watched the moon landings and was really excited about space and astronomy and bought me a bunch of space books. And he woke me up early in the morning and said, come on, let's go watch the TV. Something really important is happening. And so we watched the launch of the first space shuttle, and it was great. And I don't remember a lot, but I definitely remember that the rocket taking off live. And so, now I, went through my career, and I'd never watched a rocket launch. And so in 2011, I sort of stars aligned, and I decided, okay, this is it. This is the time I'm going to watch a rocket launch. I'm going to report on site. And so I signed up to get a press pass to go to the launch in Florida. And of course, I live in Western Canada. It's really hard to get to Florida from Western Canada, Vancouver Island. And I paid for a flight for my father. And my father is a professional photographer. And so it was pretty straightforward to get, give him the camera. And then I could do my job doing the reporting. And so we got out there and we got a chance to see the space shuttle, which was amazing. And we got a chance to sort of attend some press conferences and talk to other people and go into see the vehicle assembly building and just sort of tour the facility and so on. And then the space shuttle got delayed, and then it got delayed again. And then we had a couple of days. And so we went down to Miami and then came back. And then they got delayed for a month because of a problem with the fuel tank. And so that was that. So we had to leave. And then a month later, the space shuttle launched just fine. And so I missed it. So should you go? Yes, you should go. What are the odds of cancellation? I don't know, man. If then you had a road trip and you saw it, and you'll at least see the Starship, hopefully. But if it flies, then you will experience the majesty of a rocket launch. And I think, we have to take those risks. You miss, what is it? You miss 100% of the bats you don't take. I don't know, some baseball metaphor. Anyway, so yeah, go, do it, watch it. And if it works, then you lived it. If it doesn't happen, go next time. Sean Marson. Hey Fraser, would the lower gravity at Mars make it a more reasonable possible to try to build or use a space elevator there? Sure, yeah. The gravity on Mars is a third, or the surface gravity you experience is about a third of what you experience on Earth. And so that would make building a space elevator feasible within the laws of physics as we understand them today. While building a space elevator on Earth, right now we still don't have the unobtainium that you need to be able to build the space elevator. While the one on the moon, you can build with materials that we have today. But Mars is right in between. We don't actually have the material to be able to do it, but it doesn't feel like it's going to be impossible for us to build it. But an idea that I've heard that I really like is instead of building a space elevator on the surface of Mars, you build a space tether coming down from Phobos, which is this moon that's orbiting Mars very closely. It only takes like 8 hours to go around Mars. So you could build this tether down from Phobos to about 100 kilometers above the surface of the Mars, sort of out of the atmosphere of Mars. And so it's a lot easier as you're launching payloads off of the surface of Mars. You just have to reach that tether and then dock with that and then climb the elevator up to Phobos, and you have a station on Phobos that would act like a gateway to the Mars system. So I like that idea. I'm less enthusiastic about space elevators in general, just because of how well the path of fully reusable two-stage rocketry is going these days. Like Starship is going to make launch costs about as cheap as a space elevator, and yet you can have them go anywhere. You can have them go point to point. You can go to other worlds. They can turn into space stations. Like there's all kinds of other advantages. Like space elevators were devised at a time when we really didn't have other inexpensive ideas for how to get to space. And now fully reusable two-stage rockets there's going to be like no cheaper way to do it. Maybe a fully reusable three-stage rocket. But anyway. Mitch Harpino, what's the one mystery of the universe that you would most like to know? I would like to know what caused the Big Bang, or what came before the Big Bang, if anything did. Like, you can roll the universe back and we can see earlier and earlier times when stuff in the universe was closer and closer together. But you get to, mathematically this first point where everything in the universe was much more densely packed together, and yet the entire universe, possibly infinite universe, was all still there. It's just less dense. And so the amount of universe has always kind of been the same, just the density has been changing over time. And so how did you get that? Now, obviously, theists will say, God did it, but, that's not an answer. It's an answer, but it's not an answer backed up by evidence. And so you need some kind of explanation. And even if you do come up with, there was like another membrane that was crossing into this universe and blah, blah, blah. Well, where did the membrane come from? And how did that happen? And it's just like, it's back to that literally like first question that a child asks, like, why is there something and not nothing? It's such a profound thought. And we'll probably never get the answer to it, because we'll always have to just kick the goalpost back another level where you're like, okay, fine. We know that the universe exists because of crashing membranes. You're like, well, where did the membranes come from? Right? The universe is a simulation. Okay, fine. So where did the people who live in the level up from the simulation come from? Oh, they're in a simulation too. Well, where did the people above that come from? They're in base reality. And where did they come from? Well, they came from a universe. Where did that universe come from? So that is, I think, the question that we will never get a fulfilling answer to, because even if we can get at what came before this universe, we'll never be able to get at what came before that universe. And it shows you, I think, that you have to be okay with mystery. You have to be okay with mysteries that can never be solved, that we can never know the answer to. And we can still live our lives. It's just fine. We'll be fine. Martin Hahn. Why does no one seriously talk about the gravity problem of inhabiting Mars? Humans on the surface is not sustainable, not even considering radiation, nearly zero surface pressure. So, when we talk about the idea of human beings living on the surface of Mars, there's sort of two parts to it, right? Like, one is human beings going to Mars for a station where they go for a couple of years, they hang out on the surface of Mars, doing science, and then they return to Earth, and maybe they go to a rotating space station after they've completed their science work. And I think we can feel pretty confident that that's going to be fine. I mean, we know that astronauts can live for a year plus in zero gravity, and they experience some health issues. Some they're able to mitigate, but they're able to come back to regular Earth gravity and go about their lives. And so I think we can be pretty safe that you can send humans to Mars for a little while and it should be fine. But the question is, can humans live on Mars for long periods of time in the low gravity? And the answer still is we don't know. What happens to the human fetus in 30% gravity? We don't know. Now, it might be that the gravity on Mars is fine, that it's enough, that human beings will be able to have children, that animals will be fine, that it just turns out that we are evolved to be able to adapt to lower gravity. And it might mean that all babies are, stillborn, which would be awful. And so it makes sense for us to figure that out first before we, commit that experiment of having humans attempt to gestate fetuses to term on Mars. So it might very well be that if you're pregnant, you have to go to space and live in the Martian O'Neill cylinder for the gestation period. There are some ideas about mitigating gravity. There's this idea of a gravity train where you have this big rotating train that is at an angle, and so it's going at a certain speed, so you get centripetal force from that, artificial gravity from this gravity train balanced with the lower Mars gravity, and you could probably dial it up to the point that we know humans can be carried to term safely. But so I think that, but again, like that's crazy. Like, you've got this giant train that's constantly, you're essentially living on a space station, but you're on the surface of Mars. So it's definitely going to be a challenge. These ideas that we're going to send millions of human beings to Mars, they're going to live just fine, is an unknown. We don't know the answer yet. And to say that we do is to be not prudent. I suspect the future of humanity is living in space. When you can finely tune the artificial gravity, you can protect from the radiation with water or some kind of shielding, then you can sort of control the environment. But we still don't even know how to create a closed environment at this point. So there are many, many things that have to be solved before we can have humans living on Mars. But that is the big one. Like, I think you can mitigate the radiation, you can deal with the pressure, just wear a spacesuit, you can hide underground, but we don't know what the low gravity is going to do. So we're going to have to find out. And I hope somebody does an experiment where they have a space station that goes at Mars gravity, and they have various mammals gestate to term, and we see what happens. And then we go to Mars and we have various animals gestate to term on Mars as we get closer and closer to human beings to see what happens, to find out if it's safe. Floversea. What astronomy career is good if I'm bad at maths? No, I don't think you're bad at math. I suspect that you have run into problems in math, you have sort of had a difficult time with them and just kind of noped out of doing the math and said, well, I'm bad at this thing. But the reality is that very few people are just naturally good at a thing like math. It's a muscle that you practice. You chip away bit by bit. You recognize patterns. You understand how the different pieces of math work. You drill them again and again and again until you get better and better, and you're able to work on more complicated versions of it. And with astronomy, in general, like if it's astronomy, not necessarily astrophysics, the math is relatively simple. And you will do the same calculations again and again and again. And you will eventually, you'll have a computer program that you use that does the math for you, that you programmed. If you do choose to go into some of the more complicated things like magnetoplasma dynamics or astrophysics, working out the event horizon of a black hole, well, you chose that life. So when you talk to a lot of the astronomers out there, very few of them say, oh, I was a genius at math. They become the mathematicians. People who are really good at math just become mathematicians. Most astronomers, they're in for the astronomy side, and the math is sort of the thing you have to do. So I think it's a negative way of looking at it. Like, don't think that you are bad at math. You just haven't practiced enough. And if you sit down and you take something that you think you're bad at, and you spend hours practicing that thing, you will get good at it. Think about video games. Right? Like, you tell people, oh, I'm bad at video games. And yet you can see people who can rise up in the ranks, get better and better and better, learn all the tricks and techniques, and eventually rank very highly in a various video game. I've picked video games and ranked highly on them just through drilling and learning each part of it. So don't say you're bad at math. Just either you're not willing to put in the work to get really good at it. And that's totally fine, right? Like, it's hard and it's difficult, and you don't have to do it. But if you want the career in astronomy, then you have to overcome this. And the way you overcome it is just by chipping away at it bit by bit, learning, practicing, drilling, until this stuff all becomes second nature to you. And you can do it. I believe in you. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts, and I'll put a link in the show notes. Thanks to everyone watching here on Twitch and to everyone who asked a question. If you want to ask a question for an upcoming show, you can post it in the YouTube comments or in Patreon, or join me live on my YouTube channel every Monday at 5 p.m. Pacific time. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano.